Okay, so finally on knowledge spillovers, I'm going to take you through very briefly my paper, which is just published. Okay. So what do I do in this paper? I'm going to take you quickly through parts of the introduction here. So, 4 contributions. Partly, I build a model with a more sensible structure than, say, the Acemoglu paper, where we have this sort of fossil economy and a clean economy. Instead of that, here we have households, final good firms, and an energy sector. And in the energy sector, so the energy sector provides inputs to the final good firms, which provide consumption to the households. And the energy sector, of course, consists of a fossil sector and a clean sector. And emissions flow actually not from here. Maybe we should have a different picture for the factory without a chimney. Emissions flow from the use of fossil fuel in the fossil sector. And we also have an extraction sector, actually. Okay. And then I do a careful, what we would call a welfare analysis, the kind of thing I've talked about in the course, like what is first best. Acemoglu talks about like, oh, you don't need an emissions tax. Well, maybe not, but in first best, surely you should always have a Pigovian emissions tax together with your instruments sorting out the knowledge spillovers. So in this paper I do a careful welfare analysis, and we'll have a look at that in a minute because it's you'll recognize it from the course, the kind of classic what would you do in first best, what levers does the regulator have, what levels of these levers will the regulator choose. Okay, then I have a novel model of what we call directed technological change, which is how researchers choose between researching here and what that gives in returns. And there's also research going on here, of course, but I treat that as exogenous. I don't model that explicitly. And crucially, I say that knowledge in these sectors is building largely on general knowledge, which tends to hold the knowledge stocks closer together and doesn't allow this seesaw kind of effect that you have in Acemoglu's paper, among others. It's still important, you can still raise knowledge here compared to here, but it's not going to go like way off. And I look carefully at second best. So remember in the Fisher paper, she sort of says, or Fisher is she, Newell is he, I think, they say, that look, actually the best thing would be to have instruments correcting exactly for each of the 3 problems. So why would you not just do that? Well, why not just correct for research spillovers? The problem is it's really tricky to correct for knowledge spillovers because it's just hard to make researchers do what you want them to do. The social planner can do it, of course, because the social planner is a made-up thing. But how would a regulator actually make researchers do exactly what she wants them to do? It's really tricky. Like I was saying, if the regulator or the government orders a bridge to be built, and 10 years later there's no bridge, you say, well, you can't have your money, we're going to take you to court, whatever. If the regulator pays some researchers to do some research, and 10 years later they come along and say, yeah, thanks, but we didn't really come up with anything, what can Stefan do? Not a lot. Okay, so it's really tricky to sort out research spillovers. So given that it's so tricky, you can't actually achieve first best. You have to try to deal with it in second best. It helps to some extent to subsidize research, but it's not going to solve everything. So what else can we do? And that's what I look at. Okay, I just want to show you this from setting up the model. We start 2.1, the market solution, we've got equations to describe what's going on, and then first order conditions. So in an optimum, these 5 things should apply, okay? And I'm not going to take you through what they are, it's fairly complicated. But then, 2.2, you can't see this at all, but page 362, the social planner solution and regulation in first best. Okay. So we can set it up as a social planning problem instead and get these first order conditions that are reminiscent of the market first order conditions but different. So here we've got a thing floating around called nu, and here we had a tau, for instance, and then we say, well look, for first best optimal regulation, we need to make tau equal to nu, and we need to make, and so on, to get these to be the same as the others, or to get the market equations to be identical to the planner's equations, to guarantee that we get the same solution. And this is like Pigovian tax, just the right subsidy to the energy sector, just the right subsidies to the research, to the 2 different research sectors. Okay. Okay, and then I have a proof that is basically to do with that standing on shoulders result that I showed you earlier. That in a growing sector where you have more and more people standing on your shoulders, research is more severely undersupplied than in a shrinking sector where there's lots of people at the bottom and then fewer on their shoulders. And it means then that in that growing sector you should have a more substantial subsidy to research in first best than in the shrinking sector. Then I say, okay, but what about regulation in second best when it's not possible to optimally manage the researchers and just make sure they do exactly what you want them to do? And I'd have some tricky stuff to kind of work out what that really means in a model, and then I have a bunch of calibration to do, and then I run some simulations. So let me just gather my breath and then think about the simulations. Okay, so then what are the results? This is a summary of some of the results. So what does this show? This shows atmospheric carbon stocks over time, and this is in the laissez-faire in the parameterized version of the model, and then the dashed line at the bottom is first best if we assume that there aren't any of these problems in telling researchers what to do and so on. But when there are problems like that and we can't achieve first best, it turns out we can get very, very close. In second best, we end up very close to the first best allocation. What's this one? This is the relative use of clean energy compared to fossil. So again, laissez-faire, we start off almost all fossil, 5% clean, and then there's still a slow transition away from fossil because, for instance, fossil is running out, right? But in first best, we have a rapid transition away, and clean energy has got more than 50% by before 2040. In second best, with these extra problems, we can't quite get to first best, but it's still more or less the same. This is the Pigovian tax. In first best, it follows this exponential rise, tracking GDP. In second best, the Pigovian tax is raised above, the emissions tax is raised above the Pigovian level. Why? To encourage clean research. And here are research subsidies. In first best, we subsidize both clean and fossil research quite heavily. Through that subsidy, we're assuming that the researchers do what we want them to do. But when the subsidies are partially wasted, we don't use them nearly as much. Plus, we differentiate strongly between clean subsidies and fossil subsidies. We hardly subsidize fossil research at all, even though there's still spillovers in the fossil knowledge sector as well. And at least initially, to kick things off, while the standing on shoulders effect is biggest, we have big subsidies for clean research. And the second okay, now I'm not going to take you through that. What we also do is test, well actually, maybe I do want to do this. Basically, what I also do in the paper is say, imagine that the regulator only has one lever. Which is it? Well, if it's PIGU or the emissions tax, you can get pretty close to first best. Or but if you've only got research subsidies, for some reason, you can't get anywhere near first best. That's basically the point. So it's kind of confirming the Fisher and Newell results. Okay, I think that's all I want to say on this paper. Let me just pause and check that. Okay, I'm happy with that paper, so that's the end.